Hello students, welcome to my channel, The Field of Chemistry. I am Vijay Lakshmi. Today we are going to discuss about preparation of amines. In that there are 5 to 6 synthesis, that means reactions we are going to check. Okay, in that first one from nitrohydrocarbons. In that, how do we get the amine? That we are going to check. Then from alkyl halide. Then from nitriles, that is cyanohydrin, that is cyanohydrocarbon, cyanide compound. Okay. Then from amides, from imides it is Gabriel Thalimide synthesis. It's very important one. That's what I mentioned here. From amide, that is Hoffmann's degradation. This is also very important question. These are the 6 reactions we are going to check in this video. Okay, let us go to that part. Okay, preparation of amines. It is aliphatic amines, aromatic amines. Both we are going to check. There are 2 ways to remember the reaction part. Okay, so I have given all those 6 reactions now. How do we remember all those reactions? Easy way I'm telling you. The first one, nitro compounds. From nitro compounds we are converting nitro compounds into amine. I have told you the first one. So nitro compounds, the compounds have nitrogen atom. The compounds which do not have nitrogen atom. These are the 2 steps we are following. So what are the compounds which is having nitrogen atom which is converted into amine? These are the 3 reactions. Nitrogen is present over there. So in this compounds, nitrogen is present, that compound converted into amines. In another part, compounds which do not have nitrogen atom, what are those things? Alkyl halide and alcohol. So these are the 2 reactions which is converting alcohol converted into amine, alkyl halide converted into amine. So in such a way they may ask the question. Okay, now first these are the 3 reactions we are going to check. So what are the first reaction? Nitro compounds, that is NO2 group. NO2 group converted into NH2. So that is the way. I hope you got it. Nitriles. Nitriles in that CN, cyanide, isocyanide, that is NC. Okay. Next one, amide. CONH2. So these are the 3 reactions. Let us discuss. Okay, nitro compounds which is having nitrogen atom. It is NO2 group converted into NH2 group. Just now I have told you. So NO2 group converted into NH2 group. Here O2 is available. Here H2 is available. So oxygen is converted into hydrogen. That means naturally that will be reducing part. So the reduction process only. So oxygen loses, hydrogen gain. So that actually naturally what process it is actually? Reduction process. So what are the reducing agent? There are so many reducing agents. Here what reducing agent we are going to check. So here there are so many reducing agents. Hydrogen bar nickel, iron bar HCl, Fe bar HCl, Sn bar HCl, that is stannous HCl, hydrogen bar palladium, hydrogen bar platinum, all these are all reducing agent. Whenever you check this reagent, that is 100% reducing agent. Believe that. Okay. Now, what compound it is? Nitroethane. CH3, CH2, NO2. It is a nitroethane. And it is treated with what it is? Sn bar HCl. It is a reducing reagent. He treated with hydrogen, that is a reduction process. No, you are getting ethanamine, CH3, CH2, NH2. See here, NO2 group only changes to NH2, not CH3, CH2. So it will not affect all these. Why do we use this reduction process? Reduction process only functional group is going to change. It will not affect the number of carbons. How many carbons are there? That much carbon will be available in the product side also. See, reactant side 2 carbons are there. Even in the product side also 2 carbons will be available. Okay, nitro group only changes to amine group. So nitroethane, ethanamine, nitro, that is what it is. Ethane, amine, ethanamine. Okay, now next one. here nitrobenzene, here aliphatic, here aromatic. Nitrobenzene, in that nitro group is there. So how come nitrobenzene converted into aniline? They may ask the question. So this is nothing, just underwent with reduction reduction process, SN bar HCl only. Here nitro, that is what it is, benzenamine, benzene amine, benzenamine. Actually it's a common name, it is called aniline. The same part, NH2, it is here NO2 converted into NH2. It's very simple. How come nitro compound changes to amine means, just it goes underwent as a reduction process. A nitro compound only changes, NO2 changes to NH2. It will not affect the number of carbons, it will not affect that whether aliphatic or aromatic, as it is same number of carbons only will be coming into the process side. Only thing which is changing means only functional group only changes. Nitro group changes to amine group. Hope you got this process. What it is? Nitro compound. From nitro compound, how do we get the amine? They may ask that question. How do we get the amine from nitro compound? That is underwent reduction process. Remember this. Next one. From nitriles and isonitriles. Nitriles is nothing, cyanide group. In IUPAC name, nitriles is what it is? Cyanide. Isonitriles is nothing, NC. You just replace that NC, CN. This is cyanide. This is isocyanide. Okay. This is isocyanide. This is cyanide. Hope you got it. Okay. Here also cyanide is converted into amine. That means CN is converted into NH2. Here also what process we are going to use? Here also reduction process only, because cyanide is converted into NH2. So naturally it will be reducing agent. So what are the reducing agent? Here H2 bar nickel, lithium aluminum hydride, sodium bar C2H5OH, that is ethyl alcohol. So this is actually one naming reaction only it comes. I'll tell you later. So these are the reducing agent we are going to use for this reactions only. See, already have told first equation, there are so many reducing agents. In each reactions there will be specialized reducing agents only we are using. Though all the reducing agents it's there also, we are using specialized reducing agent only we are using. Now in this nickel, hydrogen bar nickel we are using at 130 atmosphere. So here what we are using? Hydrogen reduction process. So here CH3CN. CH3CN is nothing, methyl cyanide. So it is a primary amine. It is called what it is? Primary amine. Methyl cyanide. Okay, methyl cyanide converted into methanamine. It is amine group. It is methyl group. Methyl amine also we can say. Methanamine, it's IUPAC name. Already I have explained in what it is in IUPAC name of that amines I have explained on my first video, that you just go through that. Methanamine, how do we get methyl amine, methanamine, it's IUPAC name. Okay, now come to this point. So here methyl cyanide is converted into methanamine through reducing process. What we are using? H2 bar Ni. Okay, now next one. Second point, I'm going to tell you that what it is. Naming reaction which is called Mendes reaction. Mendes reaction also reduction process only, but Mendes reaction, what reducing agent we are using? It is NaC2H5OH, ethyl alcohol with sodium metal, that we are going to use. So ethyl alcohol with sodium, it is actually Mendes reaction. So what is that reactant here you are using? Here also methyl cyanide. Here methyl cyanide we are using. Here for change we are using methyl isocyanide we are going to use. Methyl isocyanide is going underwent in that reduction process. We are getting here actually primary amine. Here we got primary amine, primary cyanide, it is actually CH3Cn, it is CH3NH2. But in that Mendes reaction, primary, that is CH3, only one carbon it is there. But when we are receiving the product, carbons will be higher. Why? Because ethyl alcohol is available. So here what happened? CH3 NC changes to NH. Okay, then C2H5 just we are bringing here. This is water molecules, it is reduced. Okay, now here, see here how can you give the name? Here ethyl group is there and then amine group, ethanamine. Then here one part is there. So here we are giving first preference, it is ethanamine, and here N-methyl, just we are bringing to that point, N-methyl ethanamine. So this is the IUPAC name of this compound. So what is the Mendes reaction? Mendes reaction is nothing. Methyl isocyanide is converted into N-methyl ethanamine through reduction process. So that is called Mendes reaction, which is very, very important for naming reaction. Hope you got it. Next one reaction, it is from amide, CONH2, it is from amide. Actually there are two types of reaction. One reaction, it is both are what it is, reduction process only, but different reagent we are using. The first one, lithium aluminum hydride reducing agent we are using. See, most of the amines preparations are reduction process only. Remember that this is an open secret. Okay, so lithium aluminum hydride, it is one way we are getting same number of carbon. Note the point. It is a reduction process through amide. Amide is converted into amine. Okay. How? There are two types. In that first type, lithium aluminum hydride. Lithium aluminum hydride, suppose if you are using, that means same number of carbon will be available. That means two carbons are there. Means in the product side also two carbons will be available. Only which is changing, CONH2, that is amide, changes to NH2, that's all. So CH3, NH2, like that it may change. But the another type, Hoffmann's degradation. Hoffmann's degradation, it's very, very important, and it's a naming reaction also. It's naming reactions explain about the Hoffmann degradation. Degradation, what do you mean by degradation? That means reducing. Okay, so degradation means number of carbons will be reduced. Here same number of carbons will be available. Here lesser number of carbons will be available. That means carbon, for example, two carbons is there, means here one carbon only will come in that product. Okay, remember that. So in that amide group, converted into amines, means in that two categories are there. In that first category, lithium aluminum hydride, which is coming the same number of carbons. Another type of reaction, it is Hoffmann's degradation. Carbon number will be less. So suppose if they are asking that question, explain that Hoffmann's degradation, you just remember how many carbons are there. In that less number of carbon will be available in the product. You just remember all those steps so that it will be easy to remember, that easy idea I'm giving. Okay, now come to that point. Reduction with lithium aluminum hydride, CH3CONH2, it is called acetamide. This is acetyl methyl group. CONH2, it is amide. So acetamide, it is underwent that reduction process, lithium aluminum hydride. So here you are getting CH3 CH2. See, two carbons are available. 1, 2. Two carbons are available. Here also two carbons are available. CH3 NH2 and CH3 CH2. Here NH2. This amide group changes to amine group, ethanamine. Acetamide, ethanamine. Okay, now Hoffmann's degradation we are going to check. Hoffmann's degradation, already I have told, carbon number will be lesser than from the reactant. Hope you got it. Degradation means less. Degrade, that means losing or releasing. Okay. Hoffmann's degradation, CH3C double bond O NH2, it is acetamide. 4H, that means it is underwent that reduction process. Here bromine bar KOH we are using. Here one halide as well as potassium hydroxide we are using. So here carbon number will be 2. See acetamide, here also 2 carbons are there. Here also 2 carbon, it is acetamide. Acetamide changes to methanamine. See here only 1 carbon it is available. Remember that? So whenever you are getting for the question Hoffmann's degradation, acetamide converted into methanamine. Okay, suppose if they are asking question, acetamide converted to methanamine, in which process you will get? They may ask that such kind of question also for 1 mark. Hoffmann's degradation, because number of carbons will be lesser from that what it is reactant. Okay, so here methanamine and K2CO3 plus KBr plus H2O. So this is the process for Hoffmann's degradation. Hope you got it. Next one. See, so long we have seen nitrogen atom present in the compound. That is, nitrogen atom present in the compound means nitro group is there, amide group it is there. Then next one, cyanide, isocyanide, all those 3 reactions we have seen. So that compound converted into amine, whether it is a primary amine or secondary amine, whatever it is. But nitrogen atom is present in that compound converted into amine. Now we are going to check nitrogen atom is not there. That means alkyl halide and alcohol only we are going to check. In that how that alcohol is converted into amine or alkyl halide it is converted into amine. So that one we are going to check. Remember these points. It will be easy to remember, recognize that points easily. Okay, now alkyl halide, Gabriel Thalimide synthesis, Hofmann's ammonolysis. Next one, sodium NaN3 followed by lithium aluminum hydride. Then from chlorobenzene. So these are all from alkyl halide. All these compounds converted into amine. Now we are going to check. It's very easy actually. Preparation of amines, it's very easy. And some naming reactions, you just give the importance for it. Okay, now here actually what it is, Thalimide formula. What is it? Thalimide formula. Thalimide, phthalic acid, you know very well. Benzene ring, in that COOH, it is a phthalic acid. Here Thalimide, amide group. Just now I have told amide group. CONH2, it is called amide group. Okay, now in the phthalic acid only, C double bond O, here C double bond O, both combined together it is NH. It is Thalimide. This is a formula of Thalimide. Benzene ring, C double bond O, here C double bond O, combined NH. So this is called Thalimide. In the Thalimide, KOH, see what it is, one base, strong base. Gabriel Thalimide synthesis, it's very, very important naming reaction. So KOH we are taking. So in this speciality one, I would like to tell you what is the speciality in Gabriel Thalimide synthesis. You can get only primary amines. You cannot get secondary or tertiary or a higher number of carbons amines and all. You cannot receive, though you are using Thalimide. That means number of carbons will be higher in that only. No, aromatic amine, isn't it? Aromatic amide. Okay, so even if you are using this compound also, you can get product only the primary amine. So that is one point for easy tips. For Gabriel Thalimide synthesis, we can receive only primary amine. That is the first point. Then second point, there are 3 steps are there. What are the 3 steps? In that first step, alcoholic KOHs, we are going to take it as a reactant. That means alcoholic KOH is reacted with Thalimide. That is the first step. Now second step, in that product of that reaction, RX, that means alkyl halide, it is going to react. That is the second step. Now third step, aqueous KOH, which is going to react from the product. Okay, so these are the 3 steps we are going to check. And finally, what we are going to receive? We are going to receive the primary amine. Okay, remember this. See, if you know the steps, you can get very easily the reactant. You no need to by heart, just you should understand the concept only. Okay, now we are going to take the Thalimide compound, isn't it? Thalimide treated with what it is? KOH. That is the first step. I've told you, no. So Thalimide reacted with alcoholic KOH. So what happened? This OH minus and this is plus, right? So this OH minus ion converted into OH minus ion converted in combined with H plus ion. Okay, so combined together you will get a water form, H2O. Then here this K it is going to join with. So just you bring as it is, just C double bond O, here C double bond O, N, K. So this is potassium thalimide compound which is connected with KOH. You are getting potassium thalimide. Okay. Now next step what we are going to use? Next step RX. RX is nothing, alkyl halide. Alkyl halide, whether it is a methyl iodide or what it is, Br will be available, CH3Br, anything we can use it. Okay, alkyl halide we are using. When we are using alkyl halide, what happens? Just here K it is there, no? K instead of K, here what which is going to react? Say this K combined with iodine part, you are getting what it is? Potassium iodide you are getting. Okay, then after that what happened? In this K position which is going to sit over there, alkyl group which is going to sit over there. Hope you got it. Okay, now the same thalimide, that is a thalimide compound, potassium thalimide, just you remove that K, in that place you just keep R. Okay, now third step, aqueous KOH. Aqueous KOH, what it is? Water with KOH. Okay, in that what happened? We are adding water molecules. Now in that the bond breaks. You know how this formula, because already have mentioned, so they can't understand. Wait, I'll explain to this part. See, this is a thalimide, isn't it? This is a thalimide, C double bond O. Here C double bond O. These combined together, it is N, isn't it? And then here R is there. Okay, now what happened? Here the bond breaks when you are adding the third point, aqueous KOH, you are adding, means the bond breaks. From here it is bond breaks, and from here also it bond breaks. Now what happened? HKO, in such a way it is here OK, here H, here also OK, and here H. So that means this is one compound. These are all in one compound. In such a way you remember. Okay, see here very clearly I have given COOK, here COOK, and then here NH2. See, you are getting a compound which is a product, main product. See here RNH2, from here you are getting no RNH2. See R, here NH2. Can you see that? Okay, RNH2, it's a primary amine. And then here what it is? Just you bring the same benzene ring in that COOK, potassium thalimide only we are getting. Okay. Oh, sorry, potassium thalate. Okay, it's a salt, potassium thalate you are getting. In this one simple trick I'll tell you. For Gabriel thalimide synthesis, we are going to get the product only primary amine. That is primary amine only we can receive as a product. That is one point. Second point, why do we get that primary amine only? Why can't we get number of carbons higher? That means secondary, tertiary amine, or higher number of carbons, aromatic amines and all. Why can't we get? That is the question. See, suppose if this is a concept, naturally we will ask, we will raise a hence why, what, how, all those things we can ask. So why? Because alkyl halide, in this alkyl halide do not undergo nucleophilic substitution reaction of it is what it is, potassium thalimide. It will not react with potassium thalimide. See, CH3I, that means alkyl halide, lower number of carbons will be react with that potassium halide, potassium thalimide, but higher number of carbons it will not react. Why? Because here only one group it is there. Suppose number of carbons will be more, means this also carbon, means steric hindrance will take place. So this what it is, this easily it will not go and react. So potassium and iodine, it is getting potassium iodide, easily you are getting that subproduct. But suppose if you are having a secondary halide or tertiary halide, if you are having number of carbons will be higher means, so what happened here, steric hindrance will take place. That means bulky group of carbons will be available. So bulky group of carbons means that product of what it is, potassium ion will not come and react with that what it is, number of carbons will be higher in that compound, it will not react. For that is the reason we are using alkyl halide, the number of carbons will be less. Okay, hope you got it. Aryl halide do not undergo nucleophilic substitution reaction with potassium thalimide. Okay, why? Because steric hindrance will takes place, number of carbons will be higher means steric hindrance will takes place, bulky group it is. So these are the reason we can tell. Okay, hope you got this point. So Gabriel thalimide synthesis means naturally 100% we can gain only primary amine. Even in choose the correct answer MCQs, if they ask means confidently you can answer primary amines only we can gain from Gabriel thalimide synthesis. Hope you got it this very clearly. Next one, Hoffmann's ammonolysis. Okay, Hoffmann's degradation is different. Hoffmann's ammonolysis, this is also naming reaction which is very very important. In that what we are going to receive, see, just Gabriel's thalimide synthesis opposite Hoffmann's ammonolysis. In this, we can gain primary amine, secondary amine, tertiary amine, quaternary ammonium salt. Also, we can gain all these products we are gaining from Hoffmann's ammonolysis. Hope you remember that Gabriel thalimide synthesis as well as what it is, Hoffmann's ammonolysis. Remember these tricks and all, it will be easy. You will get the confident if you get that easy tips. All those points you just points to remember in such a way you remember, so that it will be easy to attend all the MCQs. Okay. Now in that first one, Hoffmann's ammonolysis steps, alkyl halide we are using. Alkyl halide, aryl halide also we are using. Okay. Now here alkyl halide, so for example CH3Br we are taking as a reactant. In that alcoholic NH3, that is ammonia, alcoholic ammonia, we are taking all these two reactants, that means methyl bromide also we are taking plus alcoholic ammonia also we are taking, and we put it in the sealed tube, that means container should be sealed one. Okay, and we are heating. So when we heat, what happened, we are gaining all these products. What are the products? Primary amines, secondary amines, tertiary amines, and then salt, quaternary ammonium salt also. In this we can use alkyl halide, neither aryl halide. Come, let us go to the reaction part. Okay, now that methyl bromide we have taken, as I said, it is ammonia in the sealed container, and then we are heating. So first step, this is the first step. Here we are getting methanamine, that means primary amine we are getting. Okay, next one, Br changes to NH2. Remember that the first one Br, that means methyl bromide converted into methanamine, that means primary amine, one bromine atom it goes, in that place NH2. Why? Because NH3 is there now in that one hydrogen, in that Br. So combined together you are getting what it is, HBr, it is releasing. Hope you remember this. Okay, now CH3NH2, it's a primary amine. Next, second step. So this is the second step. In that second step, what happened? Again we are adding that CH3Br. Here also we are using methyl bromide. In this also, here in this also what happened? NH3 it is there, no? NH3, that in that hydrogen combined together, HBr it is releasing. That means hydrogen bromide it's coming out now. That means how many carbons will be available? Here what it is, NH, here NH2 is there, one hydrogen releases means NH only. So this methyl group and this methyl group combined together, it is a secondary amine. Okay, secondary amine, methanamine, this is methanamine. So what is the IUPAC name? N-methyl methanamine. IUPAC name very clearly I have given in that first video. How to name that IUPAC name of amines I have given very clearly. You just go through that video. Now then you will come to know very clearly how to name this product. Okay, so this is methenamine and N-methyl methenamine. This is the secondary amines where we are getting from this compound. Okay, next again we are adding CH3Br. This is the third step. In that also minus HBr. It's very interesting, like chain reaction, releasing one hydrogen and we are adding one methyl group, like that it is, right? Okay, remember this point, it is ammonolysis. Ammonia we are adding and we are losing one hydrogen for each step, so that is called ammonolysis. And what is the naming reaction? It is Hoffmann's ammonolysis reaction. In this step, hydrogen part completely it is released and HBr it's come out. So CH3N, CH3, CH3. That means three number of carbons will be available. Then it will be a bulky group, right? So how can you name that? It is methenamine. Just you give that common methenamine, then N-dimethyl methenamine. N-dimethyl methenamine. Okay, now next again you are adding that methyl bromide. This is the fourth step. Okay, what happened? There is actually, it does not have hydrogen atom to release that minus HBr, right? Now what happened when we are adding CH3Br? CH3 4 times, here 3 times, no, here CH3 4 times, N plus Br minus, it's combined together, it is a salt, quaternary ammonium salt, NH4, it's a ammonium, right? So quaternary ammonium salt we are getting. So in this 4 steps we are getting all this primary amine, secondary amine, tertiary amine and quaternary ammonium salt also we are getting. Why we are mentioning that? Because there is no hydrogen to release. In such a way it has become a salt. So we can say it's a quaternary ammonium salt. Okay, now in this also I'll give one small tip. Excess of alkyl halide. See, excess of alkyl halide, suppose if we are adding means directly major product what we are going to get, it is quaternary ammonium salt we are going to get. Excess of ammonia if we are adding means primary amine only is the major product. See here, primary amine only is the major product. Okay, you remember this. What are the reactant? Alkyl halide with ammonia. It is a ammonolysis synthesis. Remember this, ammonolysis synthesis. Explain, that means Hoffmann's ammonolysis synthesis. It's very important question. And how do we get that reaction? Means ammonia reacted with alkyl halide, whether it is alkyl halide or aryl halide, any one thing you just take it. In that sealed container you are heating, you are getting all these primary amine, secondary amine, tertiary amine and quaternary ammonium salt. Okay, in this point, excess of alkyl halide, that means excess of alkyl halide or excess of aryl halide if you are adding means quaternary ammonium salt. It's a common name, quaternary ammonium salt only you will gain. Suppose excess of ammonia if you are adding means you will get the product of primary amine. It's a major product. Hope you got it, that ammonolysis synthesis. It's very important question. Next one, treated with NaN3. Okay, followed by lithium aluminum hydride that we are using. See here also, actually what it is, from alkyl halide in that third point, alkyl halide only, it's a third point. Methyl bromide, it's a common reactant. Methyl bromide reacted with NaN3. So what happened? NaBr, these both will combine, you will get what it is, NaBr. So it is a azide. Usually N3, what can we say? It's a azide. So methyl bromide converted into methyl azide. CH3N3. See, suppose if it goes means naturally it will come here. Okay, so CH3N3 methyl azide. Again you are treating with what it is, lithium aluminum hydride. It's a reducing agent. Remember that preparations of amines, most of the reactions undergoing reduction process only. Lithium aluminum hydride we are taking. So methyl azide changes to methenamine and N2 it's a side product. Okay, remember this. Suppose if they are asking the question, methyl bromide converted into methanamine through N, if you are adding NaN3 followed by lithium aluminum hydride. So NaN3 if you are adding means what will happen? Methyl azide you will get. Again further continue with that reaction with reduction process, you will get methanamine. Okay, next one, preparation of aniline from chlorobenzene. This is also very important question. How do we get the aniline from chlorobenzene? It's a repeated questions. Many times have seen that. So, how do we get aniline from chlorobenzene? You just take that chlorobenzene. This is chlorobenzene. Chlorobenzene. Okay, chlorobenzene converted into aniline. Aniline is nothing, aminobenzene, that is NH2 in that benzene group. So that is benzenamine, we can say. It is aniline also. It's a common name, aniline. Okay, now chlorobenzene, alcoholic NH3. Here you are using alcoholic NH3, that is ammonia group. So in that one hydrogen which is going to sit over there, so you will get minus HCl. Okay, then remaining part just chlorobenzene, chlorine atom it is replaced in that NH2 will sit over there. In this Cu2O, it's a catalyst. And we are giving the temperature 200 degrees Celsius. Okay, here what it is? Aniline. So chlorobenzene is converted into aniline in the presence of alcoholic NH3 and we are using catalyst to Cu2O and 200 degree Celsius. Hope you got it. This chlorobenzene converted into aniline. Okay, next one from alcohol. From alcohol, C2H5OH plus NH3. Common ethyl alcohol we will take. Ethyl alcohol mixed with ammonia. You remember that number of reactions we are using ammonia. Why? Because ammonium derivative is only amines. Remember that point. Okay, so ethyl alcohol combined with ammonia in the presence of what it is? Catalyst we are using Al2O3, aluminum oxide, and 400 degrees Celsius. You are losing that water and you are getting what it is? C2H5NH2. This OH group, it is replaced by NH2. One hydrogen, it will go and sit over there. H plus ion. Okay, now you will get water. In that NH2 group is there, no? NH2 group will sit over here. C2H5NH2 ethanamine. Okay, easy. This is a primary amine. Again, ethyl alcohol. Again, if you are adding means what it is? Again, it is like a chain reaction. Already we have seen ammonolysis now. That also, from alcohol also, it is the same thing. So, here suppose again if you are adding ethyl alcohol, here see secondary amine, see OH group, it is going away. In this one hydrogen, it will go and sit over there. So, here NH. In that NH, C2H5, C2H5. So, how can you give the name? It is ethanamine, N-ethyl ethanamine. It's a secondary amine. Now, again you are adding C2H5OH minus H2O. Again, tertiary amine. Hope you can see this. Tertiary amine. Okay, tertiary amine, how do you get it? Again, you are adding C2H5OH in that N, C2H5, C2H5, C2H5. It is a tertiary amine. How can you name that? Ethanamine. It's a common name, ethanamine. So, here how can you give the name? NN, diethyl ethanamine. This is a like chain reaction. In that ammonolysis, you are using what it is? Alkyl halide. Here, from alcohol, you are using this. Remember these points. Number of times it is repeated. Remember these points. Okay, next one, preparation of aniline from phenol. So preparation of aniline from phenol, see preparation of aniline from chlorobenzene, also one question. Preparation of aniline from phenol is the second repeated question. See, that means how do we get the aniline from phenol? How do we get the aniline from chlorobenzene? In such a way they may ask. Remember those points. What are the important ingredients we are using? Okay, now here this is the phenol. In that ammonia we are adding. So anhydrous zinc chloride. Already we have heard about that anhydrous zinc chloride. Remember those points from where we heard that. Okay, 300 degrees Celsius minus H2O. See, in that one hydrogen it will just OH combined, you will get minus H2O, and then in this aniline. So it's very easy. From chlorobenzene it is changing into aniline, from phenol it is changing into aniline. What is the main ingredient here? Ammonia only. See, in that aniline get from phenol also. What is the next ingredient? That means phenol, it's a main ingredient. Added to that ammonia, okay, you are getting aniline. Even in that alkyl halide, chlorobenzene also is there. Now chlorobenzene also ammonia we are adding, in that we are getting aniline. Hope these are all important questions. I have repeated many times so that you will not forget. So those tips will remember and recall those points for MCQs, for 2-mark question or 3-mark question, or even number of equations they may ask you. So in that also it will be useful. You just go through my video, you will get very clear idea. Hope you enjoy my video. Please subscribe my channel and give, is there any comment? Please give me in that comment box. Like my video. Thanks for watching.